Our next great scientist was born 278 years ago today. Sir Charles Wheatstone, one of the fathers of electrical engineering, is not that well known outside of specialist circles, but he was one of the first people to make electric telegraphs actually useful. And he also invented the Wheatstone Bridge for measuring electrical resistance, which you may have used if you've ever taken a course in electrical engineering or electronics. He also helped develop the first commercially practical dynamo, which gave us the means of producing electric current at a commercial scale. He also worked on the first electric motor. So we're going to talk about all those things today. Let's do science. Charles Wheatstone was born in 1788 in London, England, the son of a banker. When he was 9, his father died and his mother raised him and his 2 siblings alone. From a young age, Charles showed an interest in science and technology, building mechanical devices and performing experiments. This was encouraged by his mother, who had been a governess before her marriage and possessed some scientific instruments from her time as a teacher. Charles was particularly interested in electricity, performing experiments with a small battery and some wires, even at the age of 13, figuring out that when he connected wires between different metals, it would cause an electrical shock. His mother recognized that he needed more guidance than she could offer him. So she sent him to the Royal Institution to study under its founder, Sir Richard Owen. However, after some time there, Wheatstone was sent to a private school near Basingstoke, run by 2 brothers named Samuel and John Bicknell. The Bicknell brothers were both deaf, which led to the popular but false claim that Wheatstone himself was deaf. At this school, Wheatstone continued his studies in science and mathematics and graduated in 1804. It was around this time that he designed his first major invention, an improved drawing frame for weaving looms. Looms are machines for weaving cloth, and they use a kind of punch card to control the patterns of thread that make the cloth. A loom programmer, essentially. These punch cards would get torn or damaged, and so Wheatstone invented a way to make the cards easier to work with. He didn't patent this design, though, because he wanted to help the workers in the industry. After graduating from the Bicknell School, Wheatstone went on to study at St. John's College, Cambridge, where he received his bachelor's degree in 1808 and his master's in 1811. He earned his living while at Cambridge working as the assistant to a chemist who analyzed materials for the mining industry. After Cambridge, he returned to London and set up his own laboratory. Around this time, he met the engineer John Henslow, who introduced him to the study of electromagnetic telegraphs. In 1816, Wheatstone patented an improved telegraph that used 5 needles to transmit letters and numbers. In 1817, he and Henshaw opened a business manufacturing these machines. But despite interest from some, including the Duke of Wellington, the company failed to turn a profit and eventually went bankrupt in 1822. Although this business failed, Wheatstone's telegraph work attracted the attention of the British government, and he was asked to demonstrate his telegraphs to officials. In 1827, he was appointed Inspector of Telegraphs for the British Post Office and began working on improving the telegraph system. One of his major contributions during this time was the invention of the Wheatstone Bridge. As we discussed in our video on Lord Kelvin, one of the fundamental problems with the development of electrical technologies in the early days was the lack of tools for measuring things like voltage, current, and resistance. Voltmeters and ammeters are pretty important, right? Well, the Wheatstone Bridge is basically a specialized tool for measuring resistance. It works by comparing an unknown resistance to a known resistance. Essentially, you put the ends of your unknown resistor into one side of the bridge, and then you tweak the other side until you get some sort of indication, usually a null in a galvanometer, meaning no current through it, that tells you the value of the unknown resistor. One thing that Wheatstone did was invent the first commercial version of a sensitive galvanometer, called the quadrant electrometer, which was much more sensitive than the ones previously available, making the Wheatstone Bridge practical for the first time. But he wasn't done there. During his tenure with the post office, Wheatstone developed several other important inventions. He built the first electric long-distance signaling telegraph line, running from Paddington Station to King's Cross Station in London. Back when I took the train from London to Edinburgh, I think I changed at both of those stations. Anyway, he also built an electric railway at the London and Birmingham Railway, which unfortunately burned down before it could be completed. Fortunately, it was replaced by a steam locomotive, the world's first to pull a passenger train. In 1837, the British government sent Wheatstone to France to inspect French telegraph systems, which were more advanced than their British counterpart. While there, he met the famous physicist André-Marie Ampère, who had studied electromagnetism extensively. Ampère had already developed a version of the Wheatstone Bridge. And while Wheatstone was initially upset to learn that someone else had beaten him to the punch, he and Ampère soon became friends and collaborated on several projects. While in France, Wheatstone developed the idea of using a battery to power a telegraph system. Before this, the telegraph required a separate source of electrical current for each telegraph station, which limited how many stations could be hooked up to a single telegraph line. But Wheatstone figured out that a single battery could send signals along the entire length of the wire. By connecting the positive terminal to one end and the negative terminal to the other. This made it practical to have multiple telegraph stations powered by a single line. In 1843, Wheatstone became professor of natural philosophy at the Royal Military Academy in Woolwich, England. There he met the engineer William Froude, who convinced Wheatstone to move with him to University College London, where Froude was a professor of civil engineering. Wheatstone joined UCL in 1846 as a professor of experimental physics. He and Froude shared a lab where they worked together on a dynamo capable of producing electric current at a commercial scale. Their first design consisted of a pair of copper discs mounted on an axle with permanent magnets in between them. When the axle was turned, current flowed between the magnets, which they measured with a galvanometer. They found that they could generate current of up to 10 amps from a 1250-pound machine. The machine itself wasn't the best design, but it was the first of its kind to produce a substantial amount of current without needing a lot of power to drive it. It was also the first to feature a commutator, which converts alternating current into direct current, a critical feature for something like a telegraph, where you need the current to flow in only one direction. The invention of this dynamo marked a turning point in the history of electricity, making it possible to power multiple devices with a single source of electrical current. Wheatstone retired from his professorship in 1879. Having been knighted in 1872, he lived another 10 years. Dying of heart failure in 1887, he was buried in Highgate Cemetery in London. Although Wheatstone is perhaps best known for the Wheatstone Bridge, the device is actually named after Kelvin's mentor, Lord Kelvin. Go figure. It's me. We should really do something about that. If you like this episode, you can watch more like it on our channel or on another platform. Also, remember to subscribe to stay informed about future episodes. Until next time, thanks for watching.